Okay, good morning everyone, and welcome to this APPG on air pollution event. We're joined today by three speakers who are going to help give their thoughts on the impact of hydrogen use and production on air quality. Geraint Davies MP hasn't been able to join us yet, unfortunately. I'm told that he will join us sooner rather than later. But I'll begin by introducing our speakers. So firstly, we have Professor Andrew Barron, who is a professor of chemical engineering at Swansea University. And we also have Alvin Orbaek White, is that pronounced correctly? He's also an associate professor of chemical engineering at Swansea University. And we have Celia Greaves, who is CEO and founder of the UK Hydrogen and Fuel Cell Association. So if we could begin with Professor Andrew Barron, if you could just introduce yourself and take us through your slides as well, please. So.
Yes, as you said, I'm a professor at Swansea University. I'm also director and founder of the Energy Safety Research Institute at Swansea on the New Bay campus. Could you put the first slide up, please? So what I want to talk about today is to give a sort of brief overview is some concepts and thoughts about adding hydrogen to natural gas. How do we get the hydrogen? What's the impact of it? So the reason I want to talk about hydrogen and natural gas is that basically we've got an ability to include or decrease carbon emissions through changes without to the gas without changing the infrastructure. And one of the big advantages of that is you've got no retrofit of housing, unlike heat pumps. This is something that can be done directly. Now, globally, the amount of hydrogen in natural gas is capped at the moment about 20%. The study that's listed on the bottom of the slide there, we've determined, oh, can you go back, please? There you go. The study that's listed on the bottom of the slide, we determined that 30% is possible with no changes to the burners. So you can go up to 30% and the customer, the home user, has no knowledge that you're saving carbon emissions and there is no change to their the cooking or heating or hot water. If you go to 50%, we have to adjust burners down below 3.5 millimeters. This is the jets, the nozzles. One of the issues that we all need to understand is if you go to 100% hydrogen, as there are quite a few plans from UK government, that requires a significant infrastructure changes. But if you did change the amount of hydrogen, so if we just went to 20% of hydrogen in natural gas, you're talking about the equivalent of 2.5 million cars being removed from the road. That's the equivalent CO2 emissions. So the impact is quite considerable. The question is, where do we get it and what source is the hydrogen and how do we incorporate it? So next slide, please. So how do we produce hydrogen? Well, there's colors of the rainbow, but we'll limit it to brown, blue, and green. And the cost of the hydrogen in each case is very dependent on different parameters. So brown hydrogen is just dependent on the price of natural gas or other hydrocarbon raw materials. Blue hydrogen is more dependent on CCUSs, the capture and sequestration. And green hydrogen, if you can go back, please, is only dependent on the electricity. And so the cost of the electricity actually defines the cost of green hydrogen, which is a bit of an issue because if you take the hydrogen and use it as a storage, as an energy vector, and then convert it into electricity, you're losing money at every step. And scale is always one of the major issues. But what if we could get green hydrogen from free electricity? And I put free in inverted commas because nothing's for free. But in the UK, we have a large amount of wasted or what's known as curtailed energy from green energy sources, wind, solar, tidal, nuclear. And all of that is basically due to limits in user capacity. Now, if we wanted to store that electricity in battery storage, that's a very large cost not only in storage, but also in infrastructure. And to give you an idea, we've got about 1.3 terawatts of wasted energy in the UK every year. So to give you a comparison, the current goal for green hydrogen in the UK plan is 10 gigawatts. So is a small fraction of the amount of energy that we're just basically throwing away. We're just not generating or not putting into the grid. And if you did use that wasted energy, you're basically producing about 5% of current hydrogen production from fossil fuels. Now, the notes at the bottom give you two books that we've published. One is on hydrogen as an energy vector, production, storage, and distribution, if anyone's interested. That gives a good overview of all the different technologies that are employed and some of the potentials. And then the other is we actually use North Wales wind farms as a case study to look at the feasibility of producing hydrogen from that wasted, that free energy, if you like. And so the results from that are very interesting in terms of at what scale does it become economically viable. Okay, next slide, please. The next question is who's going to produce the hydrogen? I mean, the typical approach is that we're going to have a centralized production with distribution in the same way that we distribute natural gas or we distribute electricity. I'm not convinced that's really going to be how this is done. Certainly, you know, if we look at brown hydrogen, it's obviously large industrial sites, but I think green hydrogen is going to evolve over time. I think the initial green hydrogen production is going to be by industry users, where they'll produce the hydrogen they need on site. And as they grow capacity, they'll become suppliers. And so that'll then be integrated with home, and it could be users, could also be home producers by using wasted energy. And we call that prosumers. And basically the idea is that you can integrate production both on the local scale and through electrolyzers or large scale electrolyzers coming into a central distribution, and the natural gas network is a perfect example of that, or it can go out into hydrogen as transportation or energy fuel itself. So the idea is that in the future, I think we're all going to be producing in the same way we're now all producing electricity with solar panels on our roofs, and that goes back into the grid when it's not being used internally within the house. So we could have the same type of approach, and we've done a significant study on the effects of that process and how do we create the infrastructure in that process. Okay, so who's going to produce the hydrogen is industry, I think, is the initial one, and I'll give another example of that. They're going to produce it for their own needs, but as we evolve, I think it will create this infrastructure approach. And next slide. Now, we talked about green hydrogen, but I can't think of a good color for this one. One of the things that we've developed is what might be called a carbon negative hydrogen production. And this comes, potential is an incredibly large scale of hydrogen production. And more importantly, it's cash positive as opposed to cash negative. This comes from basic oxygen steelmaking slag, which is millions of tons of CO2 emitted during this process, but also produces millions of tons of waste material, which is a dust or a slag. It usually has a zinc content that's too high to enable it to be reused, and it has a significant financial liability. So every steel company, and in fact the UK government, has a liability, a financial liability on this slag, because it's just a waste material that is put into mountains or essentially landfilled without really any use, and there's very little reuse of it. What we've developed is a process that allows you to take that waste slag and generate hydrogen. And the picture on the left is actually a pilot unit, a small scale pilot unit, and you can sort of see the bubbles that are evolving from the surface. And this has been a process that's been observed for some time, that slag heaps, as they get wet, under certain conditions, and that's what really the important step was, what are those conditions? But at certain conditions, you get gas evolution, and that gas is flammable. No one ever really bothered to work out what the gas was, but it's essentially pure hydrogen with a little bit of water vapor in it. And to give you an idea, for the amount of, for a 1 million ton stockpile, and in the UK, we have officially about 15 million tons, unofficially probably closer to 40 million tons of slag. And each one is equivalent to a 5 megawatt electrolyzer running 24 hours a day. But as I said, one of the biggest issues is if we look at the cost of brown hydrogen, it's about $540 per ton. Blue hydrogen's more because of the sequestration or the capture and the sequestration of the CO2. The cost of per ton of hydrogen in this case is actually a negative number. And the reason being is as a side product to hydrogen production, you actually get a zinc leachate. You actually extract the zinc, which has an incredibly high commercial value. So you offset the cost of hydrogen production by the extraction and retention of zinc. Okay, next slide, please. Oh, next slide. There we go. So the last thing I sort of want to talk about is two concepts, and one's a little tongue-in-cheek, but hopefully you'll appreciate why I've come up that way. The first one is what I like to call TRL jumping. Technology readiness level was a process developed by NASA, and it defined everything from TRL1, which was you've had a great idea and you think this is something that's really good, to TRL9 is it's in a rocket and it's going to the moon. The sort of more commercial, normal way of approaching TRLs is TRL1 is, yes, you've had a good idea. TRL9 is your technology is on an industrial site and it's integrated within a commercial process. So one of the problems is you go through, universities go through TRL 1, 2, 3, 4, maybe 5 if they're really, really pushing hard, but it's rare. And then it's up to industry or SMEs to take it from 6, 7, 8, 9. And that takes an enormous amount of time. It's about a 10-year time scale to go from 1 to 9. And I've had significant experience in that in several startups. So one of the things that we did with what's called the RICE project, which is reducing industrial carbon emissions, is decided that we take technology that was in the 4 to 5 range and jump it in one step to TRL 9 and put that onto industrial sites, integrate it into commercial processes, and then be able to demonstrate it with a long period of time. So that's one concept. And I think that's something we need to, given the shortness of time we've got between where we're supposed to hit net zero, we don't have 10 years to sit going through the TRLs step by step. We need to come up with a process that allows you to jump straight to commercial demonstration in one step. And then the second is a little tongue-in-cheek, but everyone knows about IKEA. And IKEA are famous for their architecture of their stores. I might call it the mousetrap architecture, because in order to get to the lamps, you have to go through the entire store. There's no way of shortcutting anything. But the important point about IKEA is that if you decide you want a couch or a bed or a kitchen unit, you can go into the store and you can see it in location. So you can see what it looks like in a lounge or in a kitchen or a bedroom. And therefore it becomes much easier to decide that this is something you want to buy. Well, industry needs the same thing. Not that we need an IKEA for industry, but what we need to create is a UK list of industrial site, on-site demonstrators. These can't be at a university. These have actually got to be on an industrial site, integrated. And once you've got that, of course, to get onto these sites, you have to do the HAZOP, you have to show reliability. You also have to show that it's integrated within the process. And from all of these, you get a return on investment. But once you've got these locations, even if they're not, if it's modular, but they're at a small scale, but they've demonstrated they're integrated within an industrial process, it means other industries can come along, can have a look at that process and decide whether they want to adopt it. So the photograph at the bottom is one of our hydrogen units. It's at Hanson's aggregate cement plant in Port Talbot. It's now been operating for almost 3 years. Actually started operating before COVID. And it's been so integrated within their process, they sort of forget that it's there most of the time and have to be reminded of it. And it just operates essentially blindly compared to their process. What that's allowed is multiple other industries have come, seen it, be able to talk to Hansons and understand what the advantages or issues are, and be comfortable because they know that Hansons have gone through the HAZOP process. So I think it's really important that the UK government needs to essentially attract and sort of develop this process of having a series of demonstrators of different technologies, but making them available to other industries to come and look at. Next slide. So with that, I'd like to thank you for your attention. There's some links here for the ESRI's website and the RICE Project's website, but also if anyone's interested in some of the data that's behind this, we're happy to share that. Thank you.
Thanks very much, Andrew. That was fantastic. Can I just apologise for my lateness for various technical reasons before introducing Alvin, and just say what a joy it is to see you back, and also to run through that fantastic presentation, just reminding us of the opportunities for hydrogen from off-peak renewables at scale to make a step difference. The slag heap opportunity with multi-million pounds worth of liabilities converted into assets, and obviously the process of TRL that you've mentioned in terms of accelerating into the future. And it's certainly the case from a party political point of view, if I can put it that way. From the Labour Party's point of view, are committed to investing 30 or 28 billion pounds a year on green infrastructure, that these sort of technologies will be crucial. I know your team earlier in the year when you were unwell, and it's great to see you back in full fitness again. They gave a brief presentation to Kwasi Kwarteng, who at the time was the Bayes secretary before going chancellor and then disappearing into another orbit somewhere. But I do hope we can have this presentation again to the new Bayes secretary and indeed Ed Miliband, so that we can all move forward, because the issue is doing the right thing, not who does it. We really do want to get on with it. But thank you so much. Now I'd like to invite, I'm of course the chair of the all-party group on air pollution, by the way, if anyone doesn't know. And clearly the linkage here is that if we produce this quantum of hydrogen, clearly this will have impacts for both climate change, green industrial production, and obviously air quality, insofar as hydrogen can be used for transport, as well as cooking at home, so improve outdoor and indoor air quality. So I'd like to now ask Dr. Alvin Orbaek White, Assistant Professor of Chemical Engineering, to fire away. Over to you, Alvin. Thank you.
Thank you very much, and good morning. Welcome, Geraint. Please, if you could go to the next slide, Matthew. And next slide again, please. Thank you. Yeah, so my aim is to establish, improve, and create new energy materials to ensure continued access to energy. So whenever there is failure in the energy system, we can see it ripple through our population. So for example, this winter so far has already begun to reveal some of the traumatic mental health crises we are going through due to spikes in energy costs. People are lonely, they are cold, and they are hurting. At all levels of society, we need secure energy generation, transmission, and storage capacities. And as the global population continues to grow, there is both an increasing need and demand for new generation infrastructure, whilst our aging energy infrastructure needs maintenance to keep up with the growing demands. But all of this requires vast quantities of materials. So where do these materials come from? Matthew, if you will, to the next slide. Well, if there's one thing we've learned from the global plastics crisis, oh, hit it again, please, Matthew. It seems to be, there we go. Thank you. If there's one thing we've learned from the global plastic crisis is there's lots of plastics available. So for example, on the right-hand side, you can see there, very quick calculation, for every 3 people on the planet, there's at least 2 tons of plastic waste. That's because at least 60% of all the plastic that's ever been made is errant in the atmosphere, is in some kind of waste management system. It's either controlled or uncontrolled. Now, what we've learned is the waste, when it's in the atmosphere or it's in the environment, it generates toxic gases. And there is this established in Article 1 of the Landfill Directive. There is specific guidance for monitoring trace components in landfill gas, but I'm not aware of any aspect of utilizing those gases. So in the meantime, they're venting to the atmosphere, we're breathing them in, and there's a background of toxicity in the air. Now, we've also discovered that these plastics are forming into microplastics, and the jury is still out about the long-term health benefits of microplastics. So all in all, it's not good that this is left in our environment. So what should we do instead? So please, Matthew, if you will. So using our patent pending ending process, we are able to turn these plastics and use them as a feedstock in a material synthesis process. There's a video demonstration that if you click on that video in the middle, there's a video there where you can see that the plastics is being dissolved by the plastics. There's a video there where the plastics are being dissolved by that solvent. And this is the process that we've generated, and we've published these articles on it. Effectively, what we do is you create a high density carbon sludge, and then we take this slurry and then we gasify it using chemical vapor deposition process. And in a catalytic process, we can convert it into carbon nanotubes and hydrogen. So this process is suitable for an expanding list of plastics and solvents, and it's actually very good for mixed plastics, which is a pain point for the present day plastics recycling process. So we're really looking at this as an opportunity. So in the next slide, we can see that in the UK, there's at least 14 million tons. Matthew, when you're ready on the next slide, thank you. There's at least 14 million tons of landfill plastics each year in the UK. Now, using our process, based on the calculations that we do and the work that we've done established in the lab, we'd be able to imagine that if all that plastic was polystyrene, we'd be able to generate at least 590,000 tons of hydrogen a year. Now, polystyrene is not the only plastic source that's ending up in landfill. Most of the plastic that's ending up in landfill is a mixture of plastics. So we've been working with Salt Healthcare Limited. They're a Birmingham-based manufacturer of healthcare products. We've been turning their ostomy bags into carbon nanotubes. And thanks to support from Innovate UK, we've also now been establishing how to make hydrogen from them. So we'd be able to model how much hydrogen we'd make using this background knowledge. We'd establish a best case scenario using polystyrene, 590,000 tons of hydrogen a year. Or if you imagine it being similar to the ostomy bags, which is more realistic, it'd be about 169,000 tons of hydrogen a year. If that alone was to be converted into energy using hydrolyzers, you could imagine generating anywhere between 1.9 and 6.5 gigawatts of energy. So as we go to the next slide, the reason why I created trim tabs was to take the lab scale technology and take it out of the lab, as Professor Barron was indicating, and to really show this at larger scale. So we've been doing a TRL jump very recently, and we filed patent applications to support our work. We can take plastics from a shifting supply chain, which is something that we have just experienced recently from shifting supply shocks. A variety of different plastics and a variety of different solvents can be utilized to make these tailored materials, both hydrogen and carbon nanotubes, and we're scaling these process up. We've been able to make data transmission cables. We have collaborators who are working on making batteries with these and so forth. So if we go to the next slide, what you can see is that there's an expanding list of plastics and liquids that we are able to utilize as feedstock for our process. We're able to generate hydrogen at fairly decent quantities, given the fact that they are otherwise sitting in landfill. And we are able to create carbon nanotubes, nanofibers, and graphene, and so forth. These materials and products can be utilized for electric vehicle batteries because of their high chemical durability. This gives them the ability to be recycled, as well as giving the batteries long lifetime. So that is why they are being utilized for future generation electric vehicle batteries. And I look forward to any questions or comments from the audience later. Thank you.
Well, thank you very much, Alvin. That was superb. And I know in my own case, I've recently put forward a parliamentary bill, a plastics bill, about recycling and how we combat the plastics problem, partly through fiscal measures, obviously stopping us exporting to Turkey, etc., and having a global plastics treaty. But of course, this could be a sort of golden key to the future in terms of converting plastic rather than burning it or putting it in the ground into carbon and hydrogen assets for the future. So that was really superb, and I hope we can take this forward quickly. And I will do my best to, as I say, make further connections in government and in the opposition for this as well, of course. And now, without further ado, I invite Celia Greaves, CEO and founder of UK Hydrogen and Fuel Cell Association, to make her presentation. Welcome, Celia. Thank you so much.
Thank you, Geraint, and thank you for the opportunity to talk with you today. Could I have the next slide, please? Lovely, thank you. Okay, super. So as Geraint said, I'm the CEO of the UK Hydrogen and Fuel Cell Association. We're the leading trade group in the sector. We have over 100 members that span the full hydrogen space from hydrogen production through the range of applications, and then across into other aspects such as hydrogen storage and the role in resilience. Our members represent over 200,000 employees worldwide with combined revenues of £400 million. We're a key focal point for national and international engagement on hydrogen, and our mission is all around both promoting our members and the sector, and also making sure that we've got the right policies in place so that hydrogen can deliver on its potential across energy resilience, clean growth and net zero. And we also convene the Hydrogen Coordination Forum. There are a growing number of national and regional bodies active in the hydrogen space, and through the Hydrogen Coordination Forum, we bring those groups together to look at areas of common interest where we can combine messages into government and other key stakeholders, and also opportunities to learn and share as well. If you've got wider interests in the hydrogen space and want to know more, our 2023 conference is now open for registrations at UKHFCA.2023.co.uk. So please head over there if you want more information. So I'm going to sort of take a little bit of a step back in my presentation from the really interesting insights that we've had from our two colleagues at Swansea, and I think a nice complement in terms of what we've been hearing regarding hydrogen production. I'll talk a little bit about that and then move on into the applications. So if I can have the next slide, please. Okay, so Andrew talked about hydrogen production in his presentation. I guess suffice to say, in the context of air quality, electrolytic or renewably based hydrogen gives us the opportunity to produce 100% zero emission hydrogen, no carbon, no other emissions, through the process whereby we split water with electricity through the process of electrolysis, and then we get hydrogen and oxygen. So it's fully zero emission and progressing at a reasonable pace within the UK. We've now got around 100 projects under development or in planning. And just as an example, there are many I could talk about, but Gigastack is a project involving UKHFCA members, ITM Power, Phillips 66 and Ørsted, where we're bringing together one of the UK's largest offshore wind farms, where renewably based hydrogen is going to be demonstrated, and then that's feeding into one of the largest carbon emitting industrial zones to demonstrate green hydrogen at scale. I think the generally there are three main areas that we talk about for hydrogen for net zero within the UK, which are industrial applications, transport and heating. I'm going to focus particularly on the latter of those two. So if I can have the next slide, please. Okay, so I'm going to, throughout this presentation, talk both about carbon emissions and other emissions, so NOx and so on, so in terms of air quality. So road vehicles emit around 1/3 of UK greenhouse gas emissions, and they're one of the largest sources of air pollution, for example, in London. And in particular, nitrous oxides and tiny particles are a particular component of the emissions that they produce. If we look at a fuel cell vehicle powered by hydrogen, it emits no harmful emissions at all, so no carbon and no other emissions. And we're seeing particular interest in the UK on the opportunity for hydrogen for heavy transport, so buses, HGVs, etc. They offer particular benefits in terms of range and weight. We don't have to have the batteries that we would need if we go down an electrification route. But even with cars, we're seeing much greater interest in that elsewhere, and work by the Hydrogen Council, which is a global alliance of world-leading companies in the space. Some specially commissioned work there concluded that hydrogen-fueled vehicles, so fuel cell electric cars, are the best option for larger vehicles and longer journeys, and also that they can be cost competitive with other low-carbon alternatives, such as electric vehicles, by 2030. So very much in the mix. So we've got a fully carbon and emission-free solution for a range of different transport modes on the road. if I can now move on to the next slide, please. I was asked to say a little bit about trains. So hydrogen is also a fantastic solution for trains. At present, 40% of our rail network operates with diesel. And as we all know, there are a lot of air quality and noise issues associated with that. So the alternatives as we move forward and look to improve the air quality and carbon emissions from our rail network are electrification and hydrogen. So electrification is a very costly option. Obviously, we do have that in place. Hydrogen being the new kid on the block that's now the alternative that we can consider. So electrification, as I said, very expensive at around £900,000 per kilometre. Hydrogen and fuel cell powered trains represent an ideal alternative. They, as with road transport, fully zero emission, no carbon, no other emissions. And research has found that they're cost competitive when looking at longer lengths of rail line, but that includes areas of low utilisation as well. So really interesting and positive option for improving air quality and carbon emissions on the rail network. Next slide, please. I just wanted to give you a little bit of a snapshot of some of the things that are going on in the UK to bring forward hydrogen for transport. I can talk for hours about how we can make this better. It's not an ideal picture. We would say within the UKHFCA it's somewhat patchy and there's no cohesive overview. But having said that, we have some activities in place and they are welcome. So here's a few of them. So we've had recently seen £3 million invested to establish the UK's first multimodal hydrogen transport hub. That's up in Teesside, and some of you may know that's one of the areas chosen for one of two industrial decarbonisation clusters. So there's a lot of hydrogen activity focused in that area. We've got a £200 million zero carbon freight trial, as well as a comparable trial in the bus area as well. So that will be trialling both hydrogen fueled and electric vehicles. And through the bus programme, we'll be seeing around 140 hydrogen fueled buses deployed in the Birmingham area. And we've already got one of the largest in Europe up in Aberdeen. So some nice pockets of hydrogen bus applications in some of our cities already in place. And we've also got several hydrogen chain projects underway. So one involving UKHFCA member, the University of Birmingham, working with Porterbrook, and another involving Alstom and Eversholt. And of course, we've got parallel examples going on across Europe, particularly in Germany. Next slide, please. Okay, so the other area I was asked to talk about is in terms of heating. And again, thank you to Andrew for some scene setting and other information on this particular area. So I guess a couple of context points. Obviously, we have our fantastic natural gas grid, really important national asset for the UK, which supplies over 90% of homes and businesses with natural gas currently. And it also supplies 3 times more energy than the electricity grid. So it's really important for moving energy around the country currently. And thinking about carbon emissions, heating our homes accounts for 20% of that. So another really significant source. Andrew talked about some of the options in terms of where we can go with hydrogen into the gas grid, and clearly there's a spectrum there going from 20%, whereas Andrew said we can make accommodations without too much work required, very little work required, and very little change to the user experience, right up to 100% hydrogen into the natural gas grid, where we will need to make some changes. There's a lot of work being undertaken to validate that as a way forward with a government decision plan for 2026. So looking at engineering feasibility, safety, etc., etc. We've also got a number of trials to demonstrate how blending and 100% hydrogen can work in specific locations around the country, and a plan subject to these decisions to gradually escalate the rollout through villages, towns, communities on an ever larger scale. And here we're looking at options of both boilers and fuel cells. So with a boiler, again, we get the fully zero carbon, zero pollution solution. And with a boiler, we get the option for the easy drop-in for heat only. There are some issues around NOx, they are being worked on, and we can definitely see at least 50% reduction in NOx emissions with a hydrogen boiler. But as I say, the companies providing those will be working on those, and that's all about optimising the operation of the boiler. So we can look to see significant progress with that as well. And I should just mention, combustion is also an option in the transport area, and the work that's being done there is getting NOx levels down to being on a par with background levels. So we really we should see some good progress there, and I'll already seen that. Next slide, please. So in terms of the key takeaways from this short presentation, and I'm looking forward to discussions afterwards, hydrogen offers zero emission solutions across a range of applications, and it also can play that wider role with clean growth, energy resilience. And in terms of air quality, as I mentioned, it's not only carbon emissions that we're looking at, but it's also other types of emissions as well, particulates, NOx, fuel cells. We've seen a strong foundation put in place to develop the supply side for hydrogen. So I mentioned the 50 renewably based hydrogen projects in planning. They are being stimulated by the support the government has put in place, but we do need to continue that momentum. We're seeing colleagues overseas pursuing this agenda at pace, people like nations like the States and across in the EU, lots and lots of measures in place to accelerate rollout of hydrogen. So the UK needs to maintain its game if it wants to compete in this area. And we also need to make sure that we have policy frameworks on the demand side as well as on supply, so that we can get that full picture. I mentioned that on the transport side, it's somewhat patchy. So we'd like to see a full strategy for hydrogen for transport, and thinking around things like refueling, which I haven't had time to talk about. But there's lots still to be done on the demand side. So I will stop there. Thank you for listening, and I look forward to the Q&A.
Thank you, Celia. That was marvellous. Now, can I tell people that they can put questions and answers, and there's a few arrived already in the question and answer panel. But I just want to, while people are doing that, and there's a couple I'll recite in a minute for people to respond to, just want to make a couple of very quick comments. And that is just Andrew and others that I have had a brief conversation with Ed Miliband, who's quite happy to come down to Swansea actually in the spring to see what you've got there, and maybe we can do something online before that. I wonder whether there's any interest from car manufacturers. Actually, I suppose the issue for car manufacturers is having some sort of idea of when there'll be scale production of hydrogen and a distribution network in place to marry that up with car innovation. Obviously, we've heard from the Labour Party about a GB Energy bank, and there is, of course, an infrastructure bank in place from the government. And I suppose there's a case to be made. Sorry, switch my phone off. So there's a case to be made again to present to them. In terms of the Department of Transport, again, Celia mentioned the issue of trains, and certainly where we are in Swansea, there was an issue about electrification of Cardiff, then they stopped it. And of course, there is a technical question of whether one of the solutions is to have a hydrogen link, as it were, namely to switch over to hydrogen between, for example, and this could happen anywhere in the country, we're extending out the web type thing, the railway network, that is, whether there's a facility there to switch from a diesel conversion to a hydrogen conversion, and actually whether that would, I don't know whether you've got a comment on this, whether that would reduce the weight of the train. If you took out the diesel component and substituted it for hydrogen, obviously it would be a cleaner a solution. And I'll leave it there. So moving on to the questions, we've got a couple of questions. Perhaps somebody could comment that Alistair Lewis in our audience is saying that adding small percentages of HS2 increases NOx. This is established in the literature. I don't know whether anyone wants to comment on that. And also he says that home combustion is essentially unabated, unlike energy generation, which is significant emissions controls in place. I'm not sure exactly what these comments mean, because obviously I think what we're saying in terms of home cooking, then if you were in your kitchen burning your methane, you'd be better off with a certain amount of it was coming off as water, I assume. And then there's a comment here, contrary to what Alistair suggests, so this is an argument within, I think, the chat actually, testing on H2 boilers do indeed show a 50% reduction in NOx emissions compared to natural gas, which I think is what Celia said a moment ago. But perhaps we can start with Andrew, if you've got any comments on those comments, and indeed my comments quite briefly, and then we'll go to Alvin and Celia. Thanks.
Certainly on the NOx comment, it's certainly true when you're looking at electricity generation, because the burners that are used there are much higher temperature, and NOx generation is all a function of temperature of the flame, and hydrogen does increase the temperature of a flame depending on the percentage. But one of the things we've looked at in the study that I indicated was that, especially for home burners, the amount of emissions, your NOx emissions, are not significantly changed, because your flame is not that hot to start with compared to electricity generation for turbines. And so we don't think that, even small amounts, I mean, hydrogen's already added into natural gas. And there are locations, for example, in the States, one region has up to about 20% already introduced with no NOx changes. The other thing that we talked about, this issue of the burners, for those of us that are old enough, we can remember when town gas got switched to natural gas. And that was actually the biggest change for all of us, was that the little gentleman from British Gas had to come out and change the jets on all the water heaters and so on. And so once you get above a certain percentage of hydrogen, that really is the biggest change to the process. And then also the transportation issue, and I think Cecilia will agree with this, is that the biggest impediment to using hydrogen as a transportation fuel is the infrastructure to refueling. And that's really the only limitation, because once you put that in, it does become, certainly for heavy goods vehicles, buses, taxis, a lot of vehicles which are rubbish trucks and so on, this becomes a much more beneficial fuel compared to the national grid and electricity. But I think it's all to do with putting that infrastructure in. I mean, Esri, we have our own hydrogen fuel cell car, but sometimes getting it filled with hydrogen becomes a really bigger problem. And in fact, actually driving it to Swindon to refuel, to drive it back again, actually puts more hydrogen in than a local filling station, when that works ever. So I think that's the biggest problem with the infrastructure for transportation.
Okay, thank you. Alvin, did you have any comments on those comments, my comments, or the comments in the chat?
No, I think Andrew and Celia are probably best suited to discuss that aspect. Thank you.
All right, Celia.
Yes, so I think Andrew's talked about the NOx. We've seen some chat between the participants in the background there, and as we've alluded to, I think work is going on. We will, it's inevitably an improvement on what we've got now, and it's part of our journey to net zero. So all direction of travel is in the right direction, so to speak, and we will be seeing work looking to optimize the engineering design of these systems so that NOx is as low as it can be. I fully agree with Andrew regarding transport infrastructure is a big challenge which is not being looked at by government. We're seeing in Europe plans to set a target of hydrogen refueling stations every 100 kilometres on major roads. We have nothing like that here, no targets at all. And it's a key to scaling up hydrogen for transport. And I think another point to make here is that you know, we've talked about hydrogen for heating, we've touched on hydrogen for industry, and we've talked about hydrogen for transport. All of these will feed off each other in a positive way, so that if we are rolling out hydrogen for industry, you know, we'll have places where hydrogen is being produced. You talked about how this could evolve, Andrew, and they will all be interconnected and offer benefits to each other. So we'll be able to have refueling stations close to industrial clusters, and then link those together with perhaps depot-based hydrogen for heavy transport, so that we can get a positive feedback loop developing, but we need the fundamentals in place to kickstart that.
You're muted, Geraint, sorry.
Yeah, Geraint, you're muted.
Okay, I'm back. Sorry, thank you for that. Now I'll run through a couple of these other questions if I may, and then people dip in and out as they feel. Christina Rees MP for Nice mentions that there's a global centre for rail excellence being developed in Nice, the Nice constituency, to test future trains and infrastructure, including hydrogen. And hold on, I've lost on the screen here. And you know, wonders whether including hydrogen-driven trains, is electrification of trains outdated with a massive progress on hydrogen and innovation? And indeed, you know, where does this, she asks, leave wind farms and solar power? And I assume, Andrew, actually on the latter point, clearly what you were talking about is generating hydrogen from off-peak renewables in any case, weren't you? But if anyone's got any comment on the balance between electrification, if you like, and hydrogen for the future, whether they see a sort of happy mix. And again, Danny Sims is asking about what the views are of a hybrid technology, a smaller heat pump supported by a gas network, potential hydrogen or at least hydrogen mix to cope with peak demand. Again, I don't know whether people have got comments about a sort of mixed economy approach. Courtney Depp is saying, and again, Andrew, you mentioned the temperatures. She's saying that she thought that the temperature of hydrogen burning was something like 200 degrees higher than methane. So my screen is jumping about for some reason here. And then, hold on. And Jennifer Russon is saying, thank you for the presentation, Celia. It will be very interesting. I just want to ask a question regarding the use of hydrogen for heating. You mentioned that work was in place to address the issues of NOx emissions for hydrogen in boilers. Considering that this will require much more testing, has been shown in studies to affect the efficiency of hydrogen boilers, what do you think the addition of hydrogen into the gas grid will have in terms of cost to the consumer? Considering the cost of living crisis, this must be at least important consideration. Again, Andrew may want to comment on this, because from what you were saying, Andrew, this is sort of, as it were, energy that isn't being used off peak. So hopefully the marginal cost will be relatively low. But perhaps I'll come back to the other questions. I don't know if anyone's got any comments on those comments. Over to Celia first, perhaps.
Yes, so I'm trying to keep up the questions myself. So if I can take the question on costs first, and then I will talk about all the other options of hybrids and so on. The leading boiler makers in the UK have all committed to make hydrogen ready boilers available at an equivalent cost to current boilers. Obviously, everybody is very mindful of the cost of living crisis, and that's part of the work that's going on now to look at making sure that we optimise that journey. So whether it's 20% blending or we go to 100%, looking at how we cost that out in detail and how it compares to the alternatives. I also wanted to touch on some of the other questions further up about blending of solutions, let's say, and hybrid options. Our view is that we need all of the above. So we're not saying within the UKHFCA that there won't be electric vehicles or that there won't be heat pumps. All of these solutions will have their place. Renewables absolutely critical to all of this, whichever paths we go down. So we'll continue to need renewables at scale. As Andrew said, hydrogen's a great solution for dealing with intermittency, and then you can get costs down as well. But the renewables will be at the base of a range of those solutions, but we'll need to look at all of them. Heat pumps will be appropriate in particular locations, and hydrogen will be appropriate in other locations, and similarly for transport.
You're right, you're on mute again.
What am I doing? Politician is muted. Andrew, sorry, do you want to make some comments on these questions?
Yes, I'd follow up for Celia's comments. I think she's right that a blended hybrid approach is really what's going to solve the problem. Just assuming that electric vehicles are going to be the solution is we're going to be going down a rabbit hole, basically. In terms of cost and the standard of living or cost of living, I think if you think about it from a basis that you've got companies that have invested into, let's say, a wind farm. So you own a large wind farm, you're only selling a fraction of the percentage of the electricity you can generate. So your return on investment is many, 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 many years. However, if you could turn that investment, shorten your ROI, and therefore your generation of income, because you're generating another fuel with the electricity you can't sell into the national grid, because the grid just isn't going to take it, there isn't a consumption for it, then your the business model becomes very different. And one of the things that we did in our study was looked at that change in the business model. Now, let's just assume that our wind farm owner is a little altruistic, because once they're starting to create a large income from hydrogen production, the cost of that electricity generation is lower. So I actually think that if we look at wasted energy, you actually would find our electricity cost would go down in the long term. And one of the areas that I think is key to that is nuclear power, because nuclear power stations like to operate at a constant level. They don't like going up and down. I mean, they're not like coal power stations or natural gas power stations. They like operating at a constant flow. But obviously the grid doesn't take that constant flow. There is a variability during the day and night of electricity requirements. So nuclear power stations, which would have hydrogen generation, I think is a very efficient way of doing it. And again, you're offsetting your costs. So the cost of generating electricity from nuclear power gets offset by the profitability of selling hydrogen, either as a fuel or transportation fuel or an industrial fuel. And I think that's the way in which you can impact the cost of living. I don't think that adding this technology will change that. I do think that when you're looking at complete changes in infrastructure, for example, heat pumps, and heat pumps are great for brand new housing, but they're not so good for retrofitting. But I think, that is a significant cost to the consumer and or the government for each of those conversions. Whereas taking essentially electricity we're throwing away, we're just not generating it because there's no need for it, is a burden on the electricity generators that they have to take into account. Let's say 50% of the potential generation, they're not going to actually make any money off. And if that changes, then the economics of electricity generation change as well.
Okay, and can I ask on the issue of electricity versus gas? I mean, obviously there's been a focus on hydrogen for transportation and blended into gas. Is there any benefit on the electricity side from a hydrogen production?
And you mean using it for electricity generation or taking?
But that's a separate issue, isn't it, really?
Yeah, I mean, Celia probably would have better comment on that. But you know, one of the things is hydrogen isn't really an energy source in the way that electricity is. It's a vector. It's a way of storing that energy chemically, and you can either burn it and make water again and energy, heat, or you can use it in a fuel cell and generate electricity. So it's really there as a storage facility, if you like, and then what you do with it is very dependent on what your needs are.
Right. Now we're coming to the end. I want to ask a couple of other questions, and again, there's questions. I'll reflect a couple of questions in the chat, but I wanted to ask Alvin specifically about the cost versus the benefits of waste plastic recovery in particular. You know, obviously it was mentioned that we get it from the landfill. And I was just wondering whether any numbers have been done on, you know, the cost of literally excavating it out of landfill, cleaning it down, then before processing and converting it into hydrogen and carbon nanotubes. And secondly, whether there's, you know, it's been said by the United Nations that, you know, by 2050 there'll be as much plastic in the sea as fish, and whether you feel there's any scope, or whether it's not, it's just simply not economic, to clean up some of our seas, in particular where there's enormous amounts of